D2 square root of 3 over 2. Okay, for those of you at home, we're doing 6.5 day 2 answers. They're posted now, so you can look through. This is all my work. I didn't do anything else other than make myself tiny unit circles that go with the domain. So this is my half for sine and tangent. There's my half for cosine and cotangent, inverse functions, and then sometimes I wrote little notes to myself to help me think through it, where sine is 1, that's at pi over 2, where cosine is, and I took this and flipped it over, negative 1/2. So those little tidbits help me get through the ones that are the reciprocal functions. So what ones do you want to talk through? 8, 18 and 40, okay? 26, 14 and 16. Start there? So today's review for our test, so we can just do problems till y'all feel more comfortable with them. 8 says, 8. Can you see the red? Y equals secant inverse 2 square root of 3 over 3. So we're looking for where secant is 2 square root of 3 over 3. Now, I have more practice with these, so I can flip that over easier than you might be able to, but here's what I think is that this is probably going to be the square root of 3 over 2, because these are the only things I know in the unit circle. So let's check and see. I'm looking for where, if this says secant, I'm looking for cosine, right? Is, and I think it is going to be the square root of 3 over 2. Let's take this and flip it over. 1 over 2 square root of 3 over 3 is 3 over 2 square root of 3. Rationalized is square root of 3 over square root of 3 is 3 square root of 3 over 2 times 3, which is square root of 3 over 2. But it was a good guess because there's only square root of 3 over 2, a half, square root of 2 over 2, and 1 or negative 1 and 0, right? Those are my only choices. So it's probably going to be this one, and I just did all the math to show you that it is. So now I'm thinking, where is cosine this? That was the hardest part. And then when I think about cosine, here's cosine. Square root of 3 over 2 is pi over 6. Square root of 3 over 2, 1/2. That's that point. And so where does that happen? Pi over 6. So I'm looking for the point where square root of 3 over 2 is first. And I didn't show it on all of my work here, but I visualized a little tiny unit circle here and where those things happen. I generally draw a tiny unit circle for everyone so I can write them in as a point and make sure. I did these this morning, so I did them quickly, but I also had the book to check. If I'd have gotten it wrong, I probably would have drawn a tiny unit circle to check it. Okay, so 8. So this part was probably what lost you on 8 was how to get here. Does that make sense to you, how I'm thinking through it? I'm thinking this is the reciprocal function. If I make it the function that I know and a value I know, I can figure out where it is. Okay. 8. 14. Y equals arc secant of 2. So I'm looking for where is, which one goes with secant? Cosine 1/2. Okay, reciprocal function, I can think about its reciprocal. So where is cosine 1/2? That's at pi over 3. And that one's the one I memorized. So pi over 3, I know it starts with 1/2, and so I can do that one quickly. This one, I actually have to think through. Emma.
What is the difference when it says arc?
Nothing. It's just somebody, it's like having 2 USB ports. Yeah. So this means the inverse function, and this says, hey, that negative 1 on the exponent is weird because it really means flip it. Why don't we use this? And then nobody agreed, so we used both. It's an unfortunate. It's like having the square root symbol and y to the 1/2. There are two ways of saying the same thing. Okay, 14. 16. Does this make it seem easy? Because that would be my goal, obviously, is to think about this as what one goes with it and then flip it over. And if you're good with your unit circle, then it should be easy from there, as long as you don't pick the wrong cosine because you know the range that you're allowed. Okay, so we're back to another one that's the reciprocal function, but cotangent and tangent have the same 1 values. In other words, when you flip over -1, it's still -1. So that's convenient. That's the same thing as where is tangent -1. And where's that? So square root of 2/2. This is the negative version, but I need this to be the negative version. And arc cotangent's domain is here, so I need it to be this one. Whereas tangent would be -π/4. So I need to put it here because cotangent and cosine have the same, because the asymptotes happen at 0 and pi. So that's why we use this top circle for cotangent. So this is sort of helpful, but not as much in this case because their circles are not the same, or their little half circles are not the same. So this should really be this value, which is 1, 2, 3 pi/4. 3 pi/4. Okay, y equals cosine inverse of -1/2. So where is cosine -1/2 ? In this half of a circle? It's +1/2 right here. It's -1/2 right here. These are the values, -1/2, square root of 3/2. Where is that? What is this place? 2 pi/3. It really does take you knowing the unit circle. And I don't know how much you've studied the unit circle since last week when I told you had to go back and refresh yourself. But this is the one that I memorized. Cosine starts with a half at pi/3. So I can do the rest of the pi/3s that way. I think about this one first, and then I apply the negative to it. It had to be this one, because both sine and cosine are positive here. This is the one where cosine's negative, 2 pi/3. So if you asked for 18, this would have been one that I hoped wouldn't be as hard as some of the reciprocals. Does writing the sentence help you? Because you're looking for the where, you're looking for the rating address. Okay. So 16 and 18, 26. So this is another flippy one. Y equals arc secant of -2. So this means where is, what one do we know? Not secant. Cosine. Flip it over. -1/2. We just did that conveniently. So 2 pi/3. So this is the same problem, because these are reciprocals of each other. I had a thought, it just left me. Oh yeah, having done the odd and the even, you've probably done every iteration of this that you can do. So if you can go back and try some of these harder ones, then you're good to go here. Like, as far as ones you know in your head, I don't know that there's more than they put in these problems. Ben?
Just quick clarification. So like the other one, like the other one, like 50, like the ones that are like 2. Those are basically like you just solve the inside one and then use the thing.
Yeah. And you're better off if you do the whole thing. So like 40 is what's up next. So 40 says cosine inverse of cosine of 2 pi over 4. And they thought that this was so easy that they had to make it a little bit harder by calling this 2 pi over 4. Do we know 2 pi over 4? Not in that form, but we can just simplify it and think of it as cosine inverse of cosine of pi over 2. Now it turns out that pi over 2 is in my cosine domain, so these do cancel each other out because pi over 2 is right here. But want to guarantee that you're going to get the problem right, you do this part first. Cosine of pi over 2 is what? 0. So now we have cosine inverse of 0. Where is cosine 0? Here. Pi over 2. So if you want to make sure that you've got it in the right place, then you want to do the whole thing out. So like 50 and through 56, they all had, or 52 through 56, they had two different functions. So they had cosine and cotangent, or tangent and arc cotangent, like two different functions. They didn't just cancel because they were completely different. So you did have to do the inside and then work tangent on it. Yeah. Colin?
So for number 40, you can cancel ones like those out or the inverse, and only if you know that it's going to be in cosecant.
Only if you know that pi over 2 is within the possible answer section. So if they said 3 pi over 2, you'd want to not say 3 pi over 2. You'd want to say, well, that's 0, and cosine inverse of 0 is pi over 2, not 3 pi over 2. So same kind of concept, but 3 pi over 2 wasn't in that domain, in that half circle here. So that would be more like the other one. Yes, sir. Oh, yeah. The phone in here makes a really loud noise. Second day was really helpful because then you're like, okay, I had a day to digest it and think through the stuff. I tried it, it was hard, and now. So the question, maybe you need to write that out. Where is, and that focuses your mind on where is. Calling question? 60. Okay. So then I made myself this question. Where is cosine? And this one goes with the square root of 2 over 2. I can figure that out. It's pi over 4. Cotangent of that one's my favorite because it's the same thing over itself, which is 1. Ben.
Good question. So I get like for when you have cosine and then secant, you just flip it. So like it's already a fraction, you just flip it.
Right.
And then like the other one when we did arc secant, it was -2 and then it became -1/2. That makes sense. But how come for 16 when it was -1, it was tangent is -1/3? You know what I mean?
Okay, so -1 flipped over is still -1. Here? Wait, 16. So this is -1 over 1, which is still -1 over 1. And so tangent, because tangent and cotangent of pi over 4 is the same value, it doesn't matter which one you put on top because they're the same. But if it didn't make sense, it's good to ask so we can make it click. I want it all to click.
No, you do not want to know because like